Good morning. All right, so this next lesson, 5.6, is all about the quadratic formula. So the essential question is, how is the quadratic formula even used? If a quadratic is of the form where all the terms are on one side set equal to 0 and we can't factor, then we've got to use the quadratic formula. The quadratic formula, it always works, even if the quadratic is factorable. This is like a no-fail way as long as you get to know it. All the terms have to be on one side set equal to 0. The quadratic formula, if you've got all the terms on one side set equal to 0, is the following. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Notice how it's all over 2a. So 2a is the entire denominator. I just want to stress that because I had that was one of the biggest mistakes in my previous years of teaching, is that people think only that square root is being divided by 2a, but it's everything. Anyway, and these coefficients and the constant, those positions, those coefficients, the constant, they are plugged in. So whatever's in the middle position, we're going to take the opposite sign of that. All right. So in the first example, we're going to see, okay, when do we factor? When do we use square roots? When do we use the quadratic formula? If I have a coefficient that is not 1, typically I use the quadratic formula, especially if I have an x squared and an x term and a constant. So let's use the quadratic formula for this. Just a little recall. X equals the opposite of b plus or minus b squared, square root of b squared minus 4ac all over 2a. And let's map out what a is, what b is, and so on. Notice how regular b is negative 5. So a is 3, b is negative 5, c is 1. So when we start this out and we want the opposite of b, so the opposite of negative 5, we're actually going to have 5. But when I plug it in for the next piece, I'm going to have negative 5 squared minus 4 times the leading coefficient 3 times c, which is 1, all over 2a. Now I'm going to do the parentheses, clean up this square root, clean up that denominator. So keep cleaning up the square root. So we get two solutions. I can't take the square root of 13 in my head, so I would accept this as an answer since the directions are just solve. But if I'm trying to figure out what the zeros are, those x-intercepts, I would have to separate it. So for the next part of this chapter, we're actually going to have to figure out what this is in our calculators. So my suggestion is take 5 plus square root of 13, hit enter, and then divide that answer by 6. So if you wanted to practice this, 5 plus root 13 all over 6 would be approximately 1.4, so that would be an x-intercept, a little past 1, or in between 1 and 2. And then another x-intercept would be closer to 0 on the positive side. So let's go to the next one. In this next one, because I only have an x squared term, I'm probably going to try the square root method, where I'm going to isolate the x squared term and then take the square root but include the plus or minus. So add 54 to the other side, divide by 6, and then take the square root. So x is equal to plus or minus 3. So we have two x-intercepts at 3 and at negative 3. In example 3, because I have an x squared and an x term, and since this 5 is not an even number to where I can complete the square, probably going to get the 6 to the other side and see if I can either factor or use quadratic formula. So if I can figure out what multiplies to 6 and adds to negative 5, actually that's negative 2 and negative 3, so I could factor to quickly find my zeros. So we get a 0 of 2 and a 0 of 3. If I were to do the quadratic formula where my a was 1, b was negative 5, c was 6, I would still come out to these solutions. I would just have to keep simplifying. So looking at the next problem, I notice that I have an x squared term and an x term, So I'm either going to have to do quadratic formula or factoring. Let's move both terms to one side. Since negative 2x squared is negative, I'm going to move that to the right side. I notice that they have a greatest common factor. So I'll take out an x, leaving me with 2x plus 7. And we have two zeros. X is 0. Or, well, I might have to set up a little equation because I can't do this in my head. Maybe subtract 7, divide by 2. We've got our two solutions. Again, we could have done quadratic formula. We would have just had to use 0 for the c term. So here's an example of what do we do if it's not looking familiar at all. Our gut instinct is to distribute. So let's distribute. So I notice I have an x squared term and x terms, so let's get everything to one side, set it equal to 0. Now I'm going to determine if I can use factoring or if I can use quadratic formula. So I do notice that I have a greatest common factor of 2. I could divide everything by 2. But I also want to show you how quadratic formula is like it always works, whether you can factor or not. So I'm going to use 4 to be my A, negative 2 to be my B, negative 2 to be my C. Recall that the quadratic formula, opposite of B, plus or minus square root of B squared minus 4AC, all over 2A. So opposite of B is 2. But when we plug in B, it's actually negative 2 squared. Minus 4 times the A, 4 times the C, negative 2, all over 2A. So 2 times the A number. Now let's clean it up. I'm going to keep cleaning up the radicand. So unlike the square root of 13 that we had in one of the previous examples, we've got square root of 36, which can become a 6. We can actually get two solutions. One of them being whatever 2 plus 6 divided by 8 is, and one coming from 2 minus 6 divided by 8. So our two solutions are 1 and negative 1/2. When we get integers, or when we get rational numbers, that means we could have factored this. So not only could we have taken a 2 out, but it would have multiplied. We would have been able to do multiply add or bottoms up method. So I just wanted to prove to you that whether you can factor or not, quadratic formula always will work. So on to the next one. If I want to see if I can multiply add, what multiplies to 10 but adds to negative 1 is actually nothing. So wait a second. Hold on a moment. We've got a typo. I need us to make this a minus 2 at the end. So there's still nothing that'll multiply to negative 10 and add to negative 1, so we're going to use quadratic formula. We've got our A position, B position, C position. We copy down the quadratic formula again to embed it in our brain. X equals the opposite of B. So B is negative 1. The opposite of B is going to be 1. Plus or minus B squared minus 4AC all over 2 times A. And simplify from there. So our x-intercepts are irrational, and we're going to stop there. On to the next. Now let's go back to why do we solve these equations. How we can still use the quadratic formula to figure out the zeros. Again, recall that this word means x-intercepts, where the y-coordinate is 0. So we set a 0 equal, or plug a 0 in for y, and then figure out, okay, can I use the quadratic formula? So even though I know I can factor, I'm still going to use the quadratic formula just to practice. Notice how this time the opposite of b is actually going to be negative 3. And I misspoke earlier, so because after simplifying I noticed, wait a second, we are getting irrational numbers, so we actually could not have factored this problem. Nothing multiplies to negative 2 that could add and give us a positive 3, or add to get us a positive 3. All right, so in the next one, let's do quadratic formula. again, but let's recognize that we do have a constant, or that we do have a linear term. It's just going to be 0x. So map out A, B is going to be 0, C. Notice how the opposite of 0 is still 0. And we keep simplifying. So I'm left with plus or minus 8 over 8. So really this turns into x-intercepts being plus or minus 1. So homework tonight is numbers 18 through 20. So that includes 19, and then 33, 34 on page 295. Have a good one.